Good morning, students. In last class, we discussed about what do you mean by schema refinement and how you divide the particular relation into subrelations. Okay. Now, in this session, we will discuss about what the problems are related to decomposition. Okay. So here see the use of decomposition is already you know that you split the main relation into sub-relations. Okay, the use of decomposition is to split the relation into smaller parts. Why we use the decomposition is to eliminate the anomalies. Okay, so here the question is, what are the problems that can be caused by using decomposition? Okay, and when do we have to decompose the relation? This is the two problems while we get that when we decompose a relation. Okay, so for these two problems we have two answers. Okay, so first one is, what are the problems? See, what are the problems that can be caused by using decomposition? So we are dividing our main relation into sub relations, so that when you are dividing the main relation into sub relation, when you have two problems, the two problems are called as two properties. The two properties are dependency preservation. So dependency preservation is used when, see here, the lossless join property and the dependency preservation. Okay, see, the lossless join property is if you divide the main relation into sub relations. Okay, so that when you combine the sub relations into main relation, you have to get as this data where exactly lies in the first. Okay, so I have for example, you take a relation called for example, see, this is an example. If I am dividing this relation into two categories, okay, again I am dividing the relation into again two relations called as e number, e name, and rating, and salary and how hours worked is divided into another relation. Now I have three relations, one, two, three. Okay. Again, if I combine these three relation, I have to get this original main relation. Okay, this is a process called a lossless join property. Okay, if you are dividing a main relation into sub-relations, when after dividing the sub-relations, when you combine the sub-relations, you have to get the original relation. Okay, like this. So if you get the original relation, and there will be some additional of data also. Okay, so the additional of data we will see later. Okay, next. Second one is dependency preservation. Dependency preservation is nothing but if you dividing the main relation to sub-relation, you have to divide the relation based on some integrity constraints. So enforcing integrity constraints. Okay, so that based upon that enforcing integrity constraints, you will get the original relation. So that is nothing but if you are taking the set operations or some rules like association rule, transitive rules, dependency rules, all comes under this dependency preservation. Okay, based upon functional dependency parameters, if you are dividing the sub relations, and after you get some combined relate, if you divide the main relation to sub relations by means of some the functional dependency properties, again you combine the relation, you will get a original relation. That is called as dependency preservation. Simply we can say that lossless join property is based upon attributes like which is dependent on another one, and dependency preservation is a property of enforcing constraints. Okay, one is functional dependency and second one is enforcing integrity constraints. Okay, I think you understand. Okay, so what are the problems that can be caused by decomposition means it is based upon two properties called lossless join and dependency preservation. Next, when do we have to decompose a relation? Okay, first one is if you divide your data, if you if you want to get the main relation, so that there will be what you have to do. Okay, if you second one is when you have to decompose the data, what parameters makes you to decompose a main relation into sub relation. Okay, then you use a one of the important concept called as normal forms. So the second question is, if you if if you have to decompose a relation, you have to use a one property called as normal forms. Okay, every so see, if you again will discuss according to the manner, lossless join property is, this property helps to identify any instance of the original relation. Instance is nothing but support. Okay, instance of the original relation from the corresponding instance of the smaller relation attained after decomposition. So that is, we have to identify a subpart of the original relation. From the subparts, we have to attain the new relation. Okay. And dependency preservation is, it helps to enforce some constraints on smaller relation in order to enforce the constraints on original relation. Okay, you take the original relation, you applying some enforcing constraints, and after applying enforcing constraints, that is the integrity constraints, you again get a original relation. This is a process of dependency preservation. Dependency preservation is a process of how, what, if any loss is happened in your original relation, by means of these two properties you will get the original relation. Okay, and second one is, when do we have to decompose a relation means, we have a normal forms. Every relation schema is in one of these normal forms, and these normal forms can help to decide whether to decompose the relation schema further or not. Okay, if you take a relation, so you take the relation so that there should be some anomalies. So if there is anomalies, you apply the normal forms. So based upon the normal forms work you applying, you divide the particular data into subdata. Okay, if there is a parameter of a normal form exists, then you may divide the one relation into sub relations, so that there will be, until there is no particular duplication of your data, you will decompose by means of normal forms. Okay, so that isn't we have some problems, and the main disadvantage of decomposition is that it enforces to join the decomposed relations in order to solve the queries of the original relation. The main disadvantage is, we are decomposing the relations. When you are joining the relation, we have to get a original relation. Okay, in some cases we will not get some original data. Okay, what do you mean by next topic is, what do you mean by multi-valid attributes from the tables? Multi-valid attributes means, see, this is the multi-valid attributes. Okay, this is the multi-valid attributes. So multi-valid attributes are nothing multi-valid values are multi-valid attributes. Multi-valid attributes means, this is the multi-valid. If there is no particular same column name to two or more attributes doesn't have any similar name, okay, in a relation, but we have two or more values in a tuples. Okay, so but we can say that there will be similarity between one attribute to another attribute, like id. Okay, number, id and number both are same. Okay, similarly first name and last name. Okay, and salary, it should be maybe salary and wages. So these are the similar attributes, one attribute to another attribute. But if you are saying that multi-valid attribute means two or more values, multi-value means two or more values to a particular attribute. So this is the, see, one and two, one and two, three. See, for this course title, we have two values for employee ID 100 and three values for 140. So there should not be representation like this. Okay, we have to represent the values in a proper manner. Okay, if there is multi-values means, we have to decompose that multi-values into single values. Okay, see, the second property of the relations in the above is applied to this table. Second property means, this is the second property. we can see this is not the second property, but dependency preservation we will discuss some constraints. Okay, is applied to this table. In this property, there is no multi-value attributes in a relation. There is no multi-value attributes in a relation. But if you take a relation, it should not be any multi-value values in particular relation. This rule is applied to the table or relation to eliminate the one or more multi-value attributes. Okay, if you take that particular rule, we have to eliminate the one or more values. Right? That values is a multi-value values. Okay, if consider the following example, the employee table contains 6 records. In this, the course title has multi-values. Okay, these employee 100 take a two courses like C++ and MS Office. 150 or 140 did not take any course. Okay, right? 150 do not take 150. So it is a null. Okay. Now these multi-value attributes are eliminated and shown the following like as this one. See, we have the 100 Krishna and CSC 2000, and it take the VC++. Similarly, this employee ID 100 Krishna CS 2000 MS Office. So here see 140. So we can say that sir, one question existing here, employee ID is a primary key means it is not possible. Okay, I hope you understand. If there is a primary key values in employee ID, it is not possible because we will not use 100 again. So we will not use 140 again. So if this is case is a critical case, this is a case where we use there is a primary key attribute not available in your particular case called employee ID. Okay, if there is a particular employee ID case, we can represent as this is a, we can take this as one table and another one is a another table. Okay, next functional dependency. So already you know that the functional dependencies and partial functional dependencies. Functional dependencies are nothing but which is the particular attributes which are depending on particular attribute. And partial functional dependency are nothing but if you take the particular attributes are dependent to primary key and particular attributes are not dependent on primary key. So simply an attributes, see here, well, the functional dependencies are nothing but a functional dependency is a constraint between two or set of attributes. Okay, see here for example, that employee has 4 columns 1, 2, 3, 4 that are functional dependencies on employee. 1, 2, 3. These 3 attributes are dependent on employee. Okay, this is a primary attribute. Okay, next. So 2 or more attributes which are dependent on particular primary key attribute, then we can simply say that attributes is a functional attribute. And next one is a partial functional dependency. It is a functional dependency in which one or more non-key attributes are functionally dependent on part of the primary key. So clearly see this is a employee ID. So in that employee ID, already we discussed key name, department name, and salary. These 3 attributes are dependent on employee ID, so that we can say that it is a primary key or what we call functional dependency attributes. And again, you say that there is a particular attribute called date of joining or date of course. So date of course is depending on not a primary key attribute. Date of course is depending on another primary key attribute called course title or particular non-primary key attribute called course title. So this is a partial functional dependency. So a non-primary key attribute which is dependent on not a primary key attribute, then it is called as partial functional dependency. Okay, next one. So till now we discussed about what do you mean by particular problems will comes under the decomposition and how you remove the multi-value dependencies and what do you mean by functional dependency and partial functional dependency, and finally if you take the normal form. This is an important concept. These 6 will this 1, 2, 3, 4, 5, 6. Okay, altogether we have there is no fifth normal form. Similarly we can end with fifth normal form. So among the 5 normal forms, you will get one question. Okay, in external you come from you will get come for one question. Okay, right. What is a normal form? So normal form is a normalization is a process of decomposing relations to produce smaller and well-structured relation. Okay, well-structured means which attributes are depending on which attributes. Particular attributes which is depending on one to each other can be reduced, not according to the user interest. It is decomposed by means of attributes which are depending on attributes. Okay, that is called as well structured. Okay, and you divide a large relation into small relations. So normalization is a process of decomposing. Decomposition a process of reducing. Decomposition is a process of reducing, uh, removing what we call redundancy by means of dividing large data. Okay. Similarly, the decomposition is done by means of which technique is normal forms. Okay. We to produce a smaller and well-structured relations, the user needs to follow 6 normal forms. Okay. So we have 6 normal forms. We will discuss these 6 normal forms in next session. Okay. I hope you understand the concept of these decomposition means and properties of decomposition, and all these properties of decomposition will be discussed later by means of an example. Okay, and what do you mean by functional dependency, how you can say that it is a functional dependency and it is a partial dependency, and what is the technique of normalization. Okay, thank you.